Okay, let's take a look at this practice test. I got a good feeling about this practice test. I think you're going to do great. So this first problem, Owen has a score in a card game that is 6 points away from 0. So let's analyze that first clue. So if he's 6 units from 0, here's 0. I could either be at a positive 6, or I could be at a negative 6. It says David's score is the opposite of Owen's, and it's positive. So David has a positive score. So this must be David, and this must be Owen. And it wants to know what is David's score. So David's score simply is a 6, and that's all there is to that one. Okay, in this next problem, we have two cities that had low temperatures for the day. Saranac Lake was at 10 degrees below 0, and Glens Falls was at 5 degrees below 0. Side note, Saranac Lake often has the coldest temperatures in the continental United States. It sets records all the time. So anyway, let's look at this on a number line, and we'll do it just like a thermometer. Okay, so I set my thermometer up, and we'll just call this Fahrenheit because we live in the United States. Degrees Fahrenheit. And so Saranac Lake was 10 degrees below 0. Well, here is 0, and below that is right here, 10 degrees below 0. And I'll put an S there. And Glens Falls was at 5 degrees below 0. We're get pretty cold here too. And it says write the temperature closest to 0 as an integer. Integer is just a positive or negative number, a whole number. And so the closest one to 0 is going to be Glens Falls at a negative 5. Okay, this next problem could be a little something that gets hard to wrap around your brain, but let's look at it. We have C and D on the number line. C looks like it is a negative number, and D is a positive number. And we want to know which of these is not true. Not true. Well, D, the absolute value of D, is less than the absolute value of C. Well, absolute value is the distance from 0, and you can see that D is closer to 0. It has a less of a absolute value. So that is true. The absolute value of C, its distance from 0, is less than D. Well, I would say that's false. It looks like the absolute value of C is this number. That's a big distance. And that's going to be positive. The absolute value is always positive. And D is only this, so D is smaller. So this is probably going to be my answer here. Let's look at the rest. The absolute value of C is greater than C. That's true. Okay, because the absolute value, C itself is negative. It's to the left of 0. And the absolute value of C is going to be positive. So a positive number is always greater than a negative number. And then finally, the absolute value of D equals D. That's true because the absolute value of D is positive and its absolute value is positive, so they're the same thing. If you get confused on this question, one thing you could do is you could just assign a value. It doesn't matter what you pick. You could say, well, maybe C is negative 10. It's possible that it's negative 10 because it's to the left of 0, so it would be negative. And we'll say D equals, say, 5. It's something whose absolute value is less than C because it's closer to 0. But we'll give it an easy number. And then try those with all of these. You could just put absolute value of 5. Is that less than the absolute value of 10? Well, yes, because 5 is less than 10. Is the absolute value of negative 10 less than 5? No, because the absolute value of negative 10 is 10, and 10 is not less than 5. No. And so on and so forth. Is the absolute value of negative 10 greater than negative 10? Yes, a positive number. The absolute value of negative 10 is positive. That's always going to be bigger. And the absolute value of 5, is that equal to 5? Yes, because the absolute value of 5 is 5. 5 equals 5. And so by assigning numbers, that might help you make sense of this problem. All right, this is a fun one. We're going to draw a polygon with vertices A at 4, negative 1. That's over 4 up, down 1, sorry, right there. There's 4, negative 1. There's point A. B is at 1, positive 1, and then negative 1. So there we are, right B. Okay. C is at positive 1, positive 3. positive 1 in the x direction, positive 3. And D is at a 4, 3 right here, D. And so that forms a nice rectangle. And now I'm looking for its perimeter. And so the perimeter is the distance around. So I have CD, which is also the same as BA. And that equals, I could take the coordinate of D, the x coordinate of 4, take away the C is 1, is 3 units. And I could count boxes in this case. They gave you an easy one. And then CB, which is the same as DA, equals, they're on either side of the x-axis. So this is 3 units and this is 1 unit. So it's going to be 3 plus 1 is 4 units. So the perimeter, the distance all the way around, is two groups of the first side, because I have a CD and a BA, 2 times 3, plus 2 groups of the second one, because I have a CB and a DA. And that's 6 plus 8, which is 14. 14 units is my perimeter. Okay, now I need to put some rational numbers on our number line here. Remember, rational numbers can be written as ratios. So there's lots of ways you can do this. You could change these to fractions. You can change them to decimals, whatever makes you comfortable. But there's 2 that stand out that are particularly challenging. 7/4, I need to make that into a mixed number. That's 1 3/4. And a negative 9/4, well, 4 goes into 9 twice, a negative 2 with 1/4 left over. So those particular ones I want to make sure I write so I can see where they are on the number line. Also, let's see, a negative 5/10 is a negative 1/2. 5/10 is a half. And a 1 in 25/100 is a 1, 25/100 is 1/4. And a 75/100, that's 3/4, right? 75 cents. So having those all in fraction form might be the best way to do this. And as I look, the left, that's to the left of a negative 2. So the negative 2 and 1/4 makes sense there. Oh, let's look at something first. So again, if I was going this direction, I'd have a quarter, a half, 3/4, a whole. 1 1/4, 1 1/2, 1 3/4, 2 wholes, and so on and so forth. Okay, so anyway, a negative 9/4 is the same as a negative 2 and 1/4, which sure looks like right here. So I'm going to write as the original number, negative 9/4. This next point looks like a negative half. It's a negative 5/10 originally. Now we're in the positive realm. So this next point right here looks like 3/4, and 3/4 is the same as 75/100. The next point is 1 1/4, which is 1 in 25/100. And the last one should be my 1 3/4, which was 7/4. So there we go. Now part B is asking you to write an inequality. There's many that you can do, but you must compare one of the fractions to one of the decimals. So pick any fraction, any decimal, and compare them. Remember, the further to the left on the number line, the lesser the value. The further to the right, the greater the value. You're going to need to be able to put that into words yourself so that you can get full credit for this question. So I'm just going to pick the first 2. The first one, 9/4, that's a fraction, and that's less than a negative 0 and 5/10, which happens to be a decimal. I fulfilled the first part of the question. I compared a fraction and a decimal. The second part says explain how I know. And I would say something like, the further left you are on the number line, the lesser the value of the number. And negative 9/4 is to the left of 0 and 5/10. I completely described it. It's not the only explanation possible. You could talk about something being greater than the other, however you want to do it. That's just the one I chose. Multiple possible solutions here. Also multiple wrong ones. Anyway. Okay, so what are the coordinates of a point in quadrant 1 which is 5 units away from point Q on the coordinate plane. Well, first you got to know, where is quadrant 1? Quadrant 1, good old quadrant 1, is that first quadrant that you first learned about way back in elementary school. So we got to point up in quadrant, when we want to point in quadrant 1, and we want it to be 5 units from point Q, and here's Q. And so if I went over to quadrant 1, I need to go in this direction. Okay, I'm going to look at my scale. My scale seems to go, they labeled every other mark, but it goes up by ones. There's -1, -3, so on and so forth. So I need to go over 1, 2, 3, 4, 5, and I end up right here. That is in quadrant 1, and it is 5 units from point Q, and the coordinates of that are 1, 1. And that's all there is to that question. All right, for the next one, they give us 3 points for food stations at a graduation, I guess, and they want to have a 4th station, and we want to make a rectangle. So let's plot those points first. So R is a -3, -2. So -3, -2, right here. Over -3, down -2. All right, the second point, S, is at a +4, -2. So +4, -2, right here. There's point S. Point T is a +4 and a +3. So that's right here. Whoops, not right there. Point T is a +4 and a +3. So that's going to be right there. Now I want to make a rectangle. And so to make a rectangle, I need right angles. I already have this side, and I have this side. So I need the other 2 sides. So this is going to have to go off at a right angle in this direction. And this is going to go after a right angle in that direction. And they meet at this point. So this must be my last point, my 4th point. And you can see that's at a -3, +3. And so on your test, you're going to want to clearly label your point so I know what your answer is. Okay, for this next problem, I want to write an ordered pair for a point in quadrant 4. That's 4 units away from point S, which happens to be a -1 5/10, -2 5/10 on the plane. So I drew on my grid here an X and Y axis. And I need to choose a scale for it. And I'm seeing halves on there, 5/10 there. So I'm thinking that I want to make every 2 marks a whole. So when I do that, I get a 1, 2, -2, -3. Now I got to plot point S, and it's at a -1 5/10, -2 5/10. So it should be right here, point S. Now they want a point that's 4 units away from S in the 4th quadrant. So quickly, this is quadrant 1, 2, 3, 4. It makes the letter C. Remember that? Okay. Now, if I want it in the 4th quadrant, I need it over here. Okay. So I need it to be 4 units away from there. So remembering that each increment on my graph is a half, I need to go 2 units to make a whole. So there's 1 hole, 2 holes, 3 holes, 4 holes, and I end up right here for my point. And the coordinates for that are X is 2 5/10, and Y is the same as S. It's a -2 5/10. So I'm going to write up here in my answer box 2 5/10, -2 5/10. And that's how that's done. Okay, number 9. Number 9. Number 9 can be wicked hard or not too bad. We want it to reflect points across both axes and then have a pair of numbers. So basically I want to know if I take -3 and 5/10 and flip it over both axes, will I end up at this point? So I'm just going to quickly draw a coordinate plane. And I'm going to label my quadrants 1, 2, 3, 4. And I'm just going to write the signs of the coordinates in each one. So if I have a quadrant 1, I'm going to have a plus and a plus. And if I'm in quadrant 2, now my x is going to be negative, but my y is still going to be positive. In quadrant 3, both coordinates are going to be negative. And in quadrant 4, I'm going to have a positive x coordinate, but a negative y coordinate. And this is going to kind of help me check. Now, remember a couple things that we learned. As we reflected numbers across any axis, if I had, for instance, a point A and B, and I reflected AB across an axis, the A and the B never changed, just the sign changed. So if I had a point, for instance, of 2, 4, that's over here at 2, 4, right here. If I reflect that over the y-axis, right there, there's the x-axis, that's going to end up in the second quadrant. The coordinates are going to be the same, but the sign's going to change. It's going to be a negative 2, 4. See, the 2 and the 4 didn't change, but when I went to the second quadrant, my first coordinate needs to be negative. Now if I took that 2, 4 and went across the x-axis, now it's in quadrant 4. So now the first quadrant has to be positive, and the second quadrant has to be negative, but the numbers stay the same. It's still a 2 and a 4. So we can use this kind of information just to analyze these points without having to actually plot them. Now if I go across both axes, okay, if I cross two axes, say I started here, I could either go here and then here, or I could go here and then here. Either way, I end up moving diagonally. If I cross two axes from quadrant 1, I end up in quadrant 3. If I start likewise, if I start in quadrant 2 and I go across two axes, I end up in quadrant 4. So flipping over both axes sends me diagonally. And when I do that, look what happens. Both signs change. I go from positive, positive to negative, negative, or I go from negative, negative to positive, positive, or I go from positive, negative to positive to negative, positive, or vice versa. Both are going to change. So we have to look at these coordinates one at a time and first see if the numbers are the same, if they have the same value, and secondly, we have to look at the signs. So let's do that one at a time. So for my first one, I have a negative 3 and 5/10 1. So the 1 is the same, and negative 3 and 5/10 actually is the same as 3 and a half. So that's the same. So then I got to ask myself, what's happening to the signs? Did the signs of both numbers change? Well, this was a negative 3 and a half, and I went to a positive 3 and a half. And 1 went to a negative 1. So that one looks like it fits the bill. Let's look at the next one. We went from 5 and 4/10 to 2. So the x-coordinate changed. So this is not any kind of reflection. Even though the numbers just flip-flopped, it doesn't work. The third one, a negative 1 and 1/4, is the same as a negative 1 and 2500. So that's the same as this one. And 3 is the same as this one. But if we look at the signs, although the sign of the x-coordinate changed from negative to positive, the sign of the y-coordinate did not change. It stayed negative. No good. This one, my x started out as 2 and 3/4 and went to a 4. No good. And this one, 2 and 5/10 is 2 and a half, and 3 and 5/10 is 3 and a half. So that piece is good. We went, they're the same values, but then the signs, look at the sign, positive to negative, that's awesome, but then positive to positive did not change. Both have to change. All right, the last problem. Che is drawing a map of his family flower garden. He wants to plant sunflowers because they make everybody happy. 6 feet away from the verbenias and 5 feet from the zinnias. And we have this graph here where all the zinnias and verbenias and cannas are. And so I'm just going to kind of play it by ear here. I'm just going to check it out. So I need to be 6 feet away from the verbenias. Verbenas, I don't know, any florists out there? And I look at my graph, and I'm going to have to assume that each of these marks is a foot. It doesn't say that. So if I went this direction, 1, 2, 3, 4, 5, 6, by trial and error, that puts it there. And then I'm going to check the zinnias. So this is 1, 2, 3, 4, 5. Look at that, it worked. So it looks like the point is a -2, +2. And so I just want to clearly label that. The sunflowers go right here. Sunflowers go right there at -2, 2. And I'm going to circle my answer so that it's very clear what's going on here. All right, if you have any questions, please get in touch with your teacher, and good luck with this. This test is totally doable.